for having me tonight, and thank the host for putting all this on. It's been very professional, very well run, up until now. I might ruin that. But yeah, no, it's an honor to be in the same room as some engineers and designers who build one of my favorite UK-based sites, which is iPlayer. Now, I didn't know the theme was accessibility. Otherwise, I would have made something a bit more accessibility focused. But I'm going to pitch this as accessibility for developers, because what I'm here today is to talk about simple and how we keep, well, we've built up a lot of complexity in the web development space over the last few years. And as a developer designer myself, it all got too much. And so this is a story about how I overcame that problem, I guess. So for a start, this is me. It's Luke Jackson with 2 N's. 1 N is a professional boxer. I'm not a professional boxer. I'm available on Twitter and GitHub. A bit of background, I did computer science at Newcastle University nearly 7 years ago now, and multidisciplinary design at Northumbria. I'm now a full-time developer, front-end engineer at Formidable. We do front-end consulting, or just React dev, and Node, and things like that. So this all started a long time ago. Probably around 2016, when I moved to America. I just moved to Boston to work for CS50, which is Harvard's Introduction to Computer Science course. And as you can see, I'm a minimalist at heart. This on the left, bar some clothes that I took. It's in a bag and around the corner. This is everything I took with me to America for a year. And this attribute of my personality often finds itself reflected in my work, as you can see on the right. When I got to work there, I was nearly almost immediately tasked with making a video player for the CS50 students, which is very apt, and you might see some inspiration has been taken from my favorite video playing site. I hadn't worked with React at this point in time very much. The previous company I worked for was using Backbone, and CS50 hadn't adopted React either, or any virtual DOM framework. They were still using jQuery. I didn't want to use jQuery because I'd kind of gone off the idea of jQuery, and I wasn't allowed to use a VDOM approach like React. So I decided to go it alone and just use vanilla JS, which was quite a bold move at the time, I think. But it worked, and what's more, it still works. You can still visit video.cs50.net, and everything pops up as you'd expect. But it became quickly apparent during development of this site that some things were lacking in the JavaScript ecosystem. At the time, the language was fast evolving, and some ES5 and 6 features which actually made JavaScript bearable to work with as a language were on the horizon, but unfortunately browser vendors were still lacking behind and not really taking it probably as seriously as they should have. It was also obvious that JavaScript lacked a native module system, so JavaScript couldn't import JavaScript. That feature just didn't exist. In other languages like C and stuff, you can import files from other places, but in JavaScript you just didn't have it. You had to rely on HTML, linking everything together with script source tags, and then the orders got crazy, and the more and more you pile on, the more fragile that became. It was a big house of cards. So guess what? I guess developers being developers, we made tools. We made many tools. Some of you might recognize some of these. Aware you're mostly developers. And they all had pretty logos, which made us use them. And then a package manager appeared that allowed us to add hundreds of thousands of transitive dependencies to our projects seamlessly. All you needed now to build a website at web scale was to install half the internet and know how to configure one or more of these tools. And I actually remember David, the head lecturer at CS50 and my boss at the time. He looked around from a terminal window that was spewing out npm install. That's all it was doing at the time. It wasn't so nice back then. And he's like, what's this? And it was at that point where I realized we're doing something wrong. If coming from a guy who teaches C and is very accustomed to terminal output, was getting baffled by what he was seeing, thinking something needs to change. And the problem was that not all the tools did all the things. And so you would need to use various tools in all wonderful, weird combinations, I guess. There were no official standards. It was like the Wild West, and just like the rest of the ecosystem, everything changed seemingly overnight sometimes. And this made setting up and maintaining a reliable build toolchain for a full-time site or web application a full-time job. And I believe the industry perpetuated this attitude. I mean, now we're seeing or we did see at least, job titles like Webpack engineer, which is just mind-blowing. What I really wanted was something like CodePen. I absolutely loved CodePen up until this point, and still do now, I guess. The idea was, you input some code on the right in these 3 languages that we all know and love, and then it gets rendered on the left-hand side. And it did it every time you typed, it then appear, type, appear. And you didn't have to do anything. You didn't even have to hit save, which was a bit annoying sometimes, admittedly, but still. Yeah, it handled everything for us. And it made sharing UIs like this, like ideas, very easy, trivial. So I wanted this experience, so on my machine, I wanted my editor and my terminal. And then something happened, which was Create React App by Facebook. Who's used Create React App, by the way? So yeah, a majority of people, I'd say, just put their hands up there. It promised to deliver on simple, which was great. It was a 0 configuration, and everything you needed was behind one single dependency. You just installed, I think it was React scripts, and it just worked. And it worked reliably across environments and for the majority of use cases, which was pretty awesome. This was, at the time, a much-needed abstraction. There was just one problem, though. And now, as I've already described, I'm a minimalist, which means I have a minimalist spec laptop. And then these days, that means 128 gigabytes, even on a MacBook Pro. And one day I got told my hard drive was getting full, which was strange because I have no videos and no music on my laptop. I have no games either. It's just a machine for coding. And so I poke around the Inspector, or Explorer, and I discovered this. So every app that I was creating with Create React App, which can just be like, oh, I've had an idea, I'll create a React app, was weighing on disk 185.7 megabytes and contained 28,005 files, 5 of which were mine. 28 other 28,000, I do not know how they got there. Right, I didn't put them there, and this was disturbing. Now, I'm no mathematician, but calculations work out at 185.7 megabytes works out of 5.4 Create React apps per gigabyte. And for essentially what is a hello world application, this is terrifying. Are you kidding me? I thought, my hard drive is full of essentially node modules, right? And I could feel other faculty of science like just laughing at us, even other developers from other languages. They're like, these guys with their nose modules. I mean, Einstein managed to generalize the workings of the universe in 5 bytes. Why does it take me 185 million to describe my hello world application? It dawned on me at this point that we, as an industry, or at least I, had resigned a lot of my knowledge to node modules. I just knew how to use these tools because I was using them every day, just through repetition, not through understanding. And every time a tool changed, I was back to square one, reading the docs, figuring it out, until everything built. So I actually decided to take some time off work at this point, and started on a mission to learn by doing. I think this is the way I actually learn best, to just try it and build it. I wanted to set the goal of recreating a CodePen / Create React App-esque experience from scratch with no dependencies. I wanted to go in with no preconceptions and just implement what I needed to get my job done, which is pretty much what these tools are promising anyway. So remember these things. This is what I noticed was lacking. So I started looking into solutions for these problems. This was probably mid-2018 by now. And to cut a long story short, at least for the sakes of this presentation, the first issue of browser support for new language features was quickly resolving itself. I guess it always will be by nature. Things start as a spec, then go into sort of behind flags, and then actually released as an implemented feature in browsers. Evergreen browsers now come with out-of-the-box support with all the cool stuff that Babel used to transpile for us. Things like const and let, async await, object spread operators, along with like new string and array methods. So life was getting better. And forgetting IE, which was slowly dying in a corner somewhere, we can strike out this first point nearly immediately. No more Babel is what this meant, which definitely lifted a lot of strain from my goal. So I turned my attention to the second problem, and to do that I started a example application. So we start this application the way most people start a web project, which is with an indexed HTML, CSS, and JavaScript file. Who remembers when web projects used to look like this? Yeah, that was a good time, wasn't it? Things were simple then, much easier. But this doesn't represent a modern day web application, right? Notice here we have some static HTML in a HTML file. Are you crazy? Why would we do this when we can just get JavaScript to do this for us, right? So we go ahead and add some script tags to point at our favorite virtual DOM runtime. In this case, it was React, hosted on some CDN somewhere. Awesome. Now we have React available globally, which is a bit gross, but it works for now, so we'll carry on. We now let React handle all of our actual page content, so all the HTML that you saw was in there is now in a React render function. And instead of crying about React.createElement being such a long function name, we literally alias it as $, and then we can pass it the 3 arguments that it wants to actually render contents. Now, I know what you're all thinking. Well, probably is how will designers and their tiny little brains ever understand a function with 3 positional arguments like this? What about JSX? Well, we will get around to that. But until then, we don't have a compile step at the moment. We can't take this magic JSX language and turn it into DOM nodes under the hood. We'll need to do it manually like this. So everything's going great, but then a wild counter component appears in our project. You can see in the components folder to the left. Some reusable chunk of code, right? And this exemplifies our real issue that we're trying to get to the bottom of, which is breaking our app into logical chunks, reusable chunks. This is a sensible thing to do, right? Like everybody does this. This is probably the focus. Most of our job is naming things and breaking it into logical chunks. Writing code's actually pretty easy. So the question is, how do we get the code from our counter file into this file so that we can use it and render it as a component with React without using a bundler? Now, one of the luxuries of Create React app is that it uses Webpack under the hood that does, as it says, is pack bits of web into one big chunk. Nowadays, it actually puts into many chunks, but back then it was pretty much just one big file. But we haven't got this luxury, right? So I start asking myself, how does Webpack work? How could we implement this myself? Maybe a rudimentary version at least. So I start watching a talk by Sean Larkin, who's the dev advocate of Webpack at Microsoft. And well, I mean, like, it doesn't look too hard, right? You start with a compiler, some options, some compilation, module definitions, bit of recursion, and no. I'm not going there. This is the kind of complexity, this kind of complexity is exactly why I chose to be a web developer over, say, becoming a compiler engineer. I'm more of a font size and background color kind of guy. So there must be an easier way than this, I thought. And I turned to my favorite learning resource, which is the fount of all knowledge, Google. And I searched for require JavaScript from JavaScript. That's what I wanted, right? And I crossed my fingers. I hope for some suggestions. The top answer looks promising, in fact. It mentions Node.js, and I'm looking for a browser solution, so a bit disappointed, but I'll pursue anyway. You never know. And to my surprise, the most upvoted answer actually explains that JavaScript didn't have a native module implementation, but it starts to talk about a new specification. They call it ES6 modules. And it goes on to claim that it's actually supported by most modern browsers. This was weird. I'd never heard of it. I've been in this space for a very long time, nearly a decade, I guess, and I'd never heard of this. What's weirder is that the syntax looks exactly the same as that of which I was already doing in my Webpack builds and my Create React app builds, right? You know, import, export. And it was mind-blowing, really. So going back to our example app, where we have our index.js and our counter component. We can now see the counter component here. We make sure that the counter exports a React component here, a functional one in this instance, called counter. And then we just import it using the syntax that was in the top answer of the Google, of Stack Overflow. And that's it, apparently. That just works. So we refresh our index.html file, which we have open in the browser, and we see this. Uh-oh, red. Red's never good. Turns out you can't use ES modules with the file protocol. It kind of makes sense. You can't use many things with the file protocol. Usually we need to be on localhost or HTTP or HTTPS. So it's a shame, but fair enough. And I know what you're thinking, but Create React App comes with a dev server, and you said you were going to create something like Create React App. And I am. So I was absolutely nerd sniped at this point and spent the next week making my own dependency-free static web server with live reload. Along with some other niceties such as HTTPS, port scanning, and web tunneling, I got a little bit carried away. I could have gotten away with using just a regular package like a Zeit serve, maybe, or any other static web, like HTTP server setup. But I did want to maintain this dependency-free sort of style. And my logic was if I wrote the code, then it wasn't really a dependency, because I knew how it worked. And I called this project Server. It's on GitHub. And it turns out it wasn't that difficult to build. Trust me, I'm a designer at the end of the day. So this ended up being less than 150 lines of code and uses standard Node and browser libraries only. You could probably pass this or grok this in like less than 10 minutes. It really doesn't do that much. I'd encourage you to go check it out. So this is the experimental part of the talk. Let's just see this in action, right? I've told you all this, but are you really going to believe it? Here we have this folder setup, which you've seen in the examples. And down here, I've got the terminal, and I've written npx server. For those who don't know, npx is just a way of running node modules without installing node modules, just on the fly. So here I run this, and then we should be able to go to localhost. Oh, perfect. I opened it on the wrong screen, obviously. And now we can see here we have hello world, this is my app template, and we have a counter that works as described down here. It has its own little bit of state. It uses a hook, React hook, to maintain the count, and then we can plus and minus the count. It's got the -- reload, so if I start the code, I'll now start the counter at 69, and it reloads, and it works. So we're getting somewhere, right? We have this code on the left, output on the right, hit save, see the new code on the thing. And we haven't, no node modules, no nothing, just these 3 files that I've written, or four files. Now I know what you're thinking, and I thought this too. That seems almost too easy, right? We literally just looked at the top answer of Stack Overflow, we copied and pasted the code, and now it works. There's no way something this nice is supported on like Firefox or something like that. There's got to be a catch. Well, turns out there isn't. In fact, it's supported across the board and has been for quite a few generations of most of the evergreen browsers. The only way we can use this, turns out the only way we can use this import-export syntax is if the file is referenced by a script tag with type equals module, like this, and this is the support for type equals module. Another benefit of this is that ES module spec was actually one of the last ones to land, so if you're inside of one of these script tags, you can nearly guarantee that all other ES6 features are going to work, which reinforces this no need for Babel anymore. So strictly speaking, this is what we call a static import. And they resolve synchronously. So if you have 10 of these, I think there is a bit of fanciness under the hood. Maybe they'll all 10 start to try and resolve. I'm not sure though. But essentially, your code below these import statements won't run unless all of these files have resolved. All right, and that could take as long as it takes to resolve, as long as your server takes to respond, which is usually pretty fast, just like any other network request. They can only exist at the top level of a file. You can't just nest these down inside. And for this reason, they're pretty preferable for loading like initial essential dependencies, and they lend themselves quite well to things like static analysis and tree shaking. But if you static import everything, like I said, if you had 20 of these at the top of your page, you could end up pulling in more code than your app needs at that moment in time. So if you would like to defer loading of a module to any other time, which is not at the very start, you can use a dynamic, what's called a dynamic import, which is this syntax here. This is especially useful if you want to load a module conditionally or lazily, as people often refer to it to. Perhaps maybe you want to swap whether you're loading development version of React or production version of React based solely on the URL, for example. If you're on localhost, go ahead and load dev. If not, load production. Those kind of things. It opens the door up for a lot. And in combination, these two are really powerful. I truly believe with the right application of these two fundamental concepts, you could scale a web app up to whatever size you like. And don't just take this from me. There's actually a really good description of this in the React documentation. And it says quite literally, the best way to introduce code splitting into your app is through dynamic import syntax. And that's straight from the horse's mouth. So the React team even created a component to handle dynamic importing of React components. And this has been available since React 16, I think, and works in combination with suspense, quite simply like this. You declare something that is going to be loaded ahead of time, and then when it gets used, it gets loaded, which is pretty cool. So earlier I flippantly admitted that I don't really care for IE users, and I don't, truly. But I know that some of us unfortunately have to care about IE users, and if you fall into that category, then you might be thinking, well, I'll just leave now. I'm never going to be able to use any of this. Well, you can think again, because luckily a very clever developer called Luke Edwards jumped on this problem quite early on and wrote a very tiny polyfill that makes ES modules just work in the browsers, I think all the way down to IE 8 or 9, which is insane to think that somebody could create this nearly overnight, and we've been waiting nearly a decade for such support. So, but yeah, very good, very interesting. Thank you, Luke. Great name as well. At this point, I'm thinking we can probably tick off the second item of the list, right? We now have multiple ways of grabbing bits of JavaScript and then using them from within our files. And these files can then grab more bits and grab more bits when files get too big. And we get all of this from the browser for free at runtime. This is zero dependency still. We haven't used any tooling, no libraries, no nothing. This is just the browser and JavaScript. So what's next, I guess? Well, as my sister once said, the world is my lobster. And at this point, I was really feeling like I could build anything at any scale with these techniques. So let's address the elephant in the room. What about JSX? As we established earlier, we know designers can only comprehend views written in JSX. And we want this approach to be inclusive or accessible, let's say, for the purpose of this talk. Usually Babel would handle the transformation of this for you under the hood. Again, that's something Webpack would employ to do and was configured to do. But surely JSX hasn't become part of web standards now, is it? Is it? Does anyone know? No, you're right. No, it hasn't. That would be crazy. It is still just a proprietary domain-specific language written by and for Facebook. But does that really mean we can't introduce it without a build step? Well, after some browsing, I came across this statement by Jason Miller, aka Developit, who is a developer / web advocate for Google. And he said, I wanted to eschew the virtual DOM, I wanted to use the virtual DOM, JSX, but I wanted to eschew build tooling and use ES modules directly. Rock on, Jason, that's exactly what I'm liking to do. I was starting to get a bit excited at this point because it sounded like I wasn't going to have to write my own JSX parser. And these suspicions were confirmed when I landed on the README of a package called HTM, which is what Jason was referring to. It describes itself as a JSX alternative using tag templates. Now, tag templates are another ES6 feature, and they work like this. So this is HTML code. It looks a lot like JSX with some subtle differences. You can see everything works. You write your JSX between HTML, and then you do these backticks, and then you go ahead and write what looks like HTML. You then use curlies to interpolate actual functions and values. Now this is pretty cool. It offers some other cool, really nice features like multiple root elements, self-closing components. You can just do dash dash at the end instead of doing dash close counter, for example. I don't think there's an example of that there, but you can do. As well as multiple root elements, which I don't think you can even do in React without HTM. All right, so I thought, sign me up. How do I use this package? And I scroll down the README and look for instructions. And it says just npm install, right? We all know that. I was like, yeah, just npm install. I don't want to npm install. We've got this far without any node modules. Is there another way? And so it says the alternative is to hot link from Unpackage by going import HTM from https://unpackage.com/htm?module. What? So it turns out imports are not strictly restricted to your application's domain. You can import scripts from literally anywhere on the internet. Now, who before this talk knew that that was possible? 2 people. This spec's been in production for like a year, and I can say I did the same talk at React Advanced maybe 4 months ago, or 5 months ago now, and only 3 out of 100 of those put their hand up too. So this is something that's drastically underknown, but this is a hugely powerful concept. This allows you to pull any JavaScript from anywhere accessible on the internet into your file and use it right then and there with no tooling. My brain was racing pretty hard at this point, and it almost sounded too good to be true. And I was thinking, well, what's this Unpackage thing? Is this all part of it? Is this some special service like NPM? It turns out it's very similar to NPM. In fact, it's a CDN mirror of NPM. It's a one-to-one mapping. Whatever is on NPM, whatever goes on NPM, if you publish something now, it'll appear on Unpackage as soon as it's requested. And it allows you to access any of those files just by URL, which is pretty cool. And for all of you thinking, well, why should we trust this random CDN called Unpackage? Well, it was made by a guy called Michael Jackson, who's a pretty well-known developer in the React community, and it is backed by Google and Cloudflare. And these guys do serious numbers. This is 80 terabytes of traffic in what looks like a day, over 1 billion requests, 560 unique IPs. This is kind of a big deal. This is not just somebody's server sat under their desk at work, a little side project. So let's go ahead and add HTM to our example, make it a little bit more designer friendly. You can see we pull it in at the imports, and then we swap up what was our dollar little hack into actual JSX, which we can use. Now, I'm aware we're a little low on time, but maybe I'll move just this one into here. Take this out. If it breaks, that's it, we're not going back. And that we should be able to uncomment this. So exactly like the documentation, it's going to break right there because we haven't got this HTM. We put this at the top, and we shouldn't need that dollar anymore. Oof, and it's back. That's it. It just went and fetched that file from the internet and then used it right here. We can now get rid of this dollar. Everyone's happy. Now you can also see that we don't have to use it everywhere. If only certain files are being touched by designers, then we can put this where we want. And otherwise, every other file can just use the old one that we were using. And that works just like as expected. Oh. So on the topic of designers, Alex promised to laugh at this point in the thing. He loves this slide. There is something glaringly missing from our setup, right? The ability to interpolate styles. But I hear you, Create React App lets you import styles, and I said I was going to build something like Create React App. So I had a Google again, and unfortunately there wasn't an ES module compatible CSS in JS library out there. So inspired by HTM's template literal approach and ES module approach, I started building one. And this worked out that I ended up calling it CSZ, and it will do pretty much what you would expect. It takes some CSS between backticks, much like the HTML, and it will generate a class name for that. So inlined here might be a class name A42282.946, and it would scope any styles that you see there under that class name. Now, just for fun, I thought I'd take it a bit further, and if you pass it slash and a file path, it will actually go fetch that file and do the same thing on top of it. And someone recently took that even further and said, well, if you pass a full URL, we'll go fetch that file, and we'll pass it, and then we'll append it to the head and give you a unique class name for that at runtime. No Babel, no Webpack, no worries. Now, it's not quite native imports for CSS, but that is not far around the corner. This is develop it again, he's at it again, and he's created this little Polyfill, which is in fact a service worker that does rewrites content type and content length, and then does some parsing on the fly at runtime, which is pretty obvious once you see it and you've sort of thought about this problem for a bit, but it's super powerful. You can literally add these, 19 lines of code into your thing, and then you can actually use that syntax up there. It'll just work, TM. So we're importing quite a lot of stuff into our project now, and it's worth reminding ourselves that with great power comes great responsibility. Short URLs are cute, short like these ones that you've seen here, CSZ, like unpackage.com CSZ, like very as explicit as we can get, given that the domain is unpackage.com. But that's about it. Like, these short source describers are really bad. I'm just going to say right now, if you are going to do this, and you're putting it in production at least, stick to this schema here, where you explicitly mention the package, the version, the file name that you want, and the extension. And if you do this, you're going to end up with more reliable, more secure, and faster apps. And that's just the end of it. All right, so back to our app, and everything is working great, but I'm looking for a few ways to improve the architecture. Two things stand out, and that is, firstly, the reliance on React, like on this window here, which will make a lot of developers grimace. And the second is this duplication and binding of HTML. It seems like there's some duplicated efforts going on here, and if you had 100 components, you would do that 100 times, which is like another 200 lines of code. So let's see what we can do about this, and let's first try address the global React issue. Now, my immediate thought was, well, if I can import HTML from the internet, and CSZ, for example, I could import React in the same way, and surely that exists, right? React is built by Facebook, and they're not a small company. Alas, it doesn't exist yet, despite there being a request for comments on this and an issue created in all the way back in November 2017. Apparently, they're still working on what top-level exports might look like. At least that's Dan's description here, which is a shame. But, a quick disclaimer, you might find yourself in this situation more often than not when taking this approach right now. Unfortunately, people still consider this very much the bleeding edge of web, and they're kind of stuck in that old bundling ways, which means most dependencies or packages like React are shipped in a way that is not accessible via this and is intended for like a script source tag, which we used at the very beginning. But if you find yourself in this situation, you have a few options, and one of them is to roll up your sleeves and get your hands dirty. And this is exactly what I did. I ended up creating a package named quite simply ES-React, and it allows you to import and use React from Unpackage exactly how we've described with other packages, and what you can do with Vue and HyperApp and other frameworks. Turns out deciding what top-level exports would look like wasn't so tough. I literally just copied what the UMD module exports already. And this is all the code changes I had to make in order to get that to work. This is it. Probably 20 lines. I changed all this mess of like export this, that, and this for just what I want, which is export default React. And this is a real good example of how much cleaner this approach makes your code. So what does this example look like in our app? Well, now we can replace that destructuring of window to import React and React DOM from ES React, which is much cleaner. Now we're really getting somewhere, but we still have this repetition, and now, in fact, we just made our repetition worse, really. We got these import statements all over the place. And there's nothing technically wrong with this, per se, but you might be thinking, well, maybe this makes double the amount of network requests, like we see 4 URLs there, not 2. Now, luckily, ES Modules and the spec has our back there. In fact, this will only ever make 2 network requests, and whichever one gets there first will cache that request within the session, and it caches it super hard as well. It actually doesn't just cache the request, it caches the parsed bytecode, which means when the second counter component comes to use this, it's lightning fast, as if it had existed all the time. For those who'd like to know more about these intricacies, you can read this article by Lynn Clark, which is very, very good. But say you are bothered about this duplication, well, it's no problem. You can create your own file, your own utility module, if you like, which imports all the things you need to build your website, like all these globals, if you like, and then just exports exactly the way you'd like it. Maybe you'd want to do this because if you want to change the version of React, for instance, across your whole app, you don't want to go into all the separate import statements and update them all to the newest version. You want to do it in one place and then have all your app feed off of this one utility file. Another warning, when you're pulling in dependencies like this, we've been lucky so far that all these projects that I've pulled in have been dependency-less. React has no external dependencies, for example. But when you do have these, this can become a problem. For example, if we would try using Prism React Renderer, this is the source code for Prism React Renderer, you can see it imports component from React. So this project is a dependency of ours if we were to use it, and that has a dependency on React. And this is a problem, because although we can rewrite our imports, when the browser comes across this, it panics. It says, what do you mean React? Where do I get React from? It doesn't understand. So how do we get them to all use the same version? Like, what if we do want to use this? Is this the end of the road for this? Well, no, it isn't. There is this proposal and a new web standard called import maps, and they look something like this. At the moment, they're behind a flag in Chrome, but you could use a package or a library called ES Module Shims, and it'll get it working for you. And essentially what this says to the browser is that every time you see import React, or React DOM, or HTM, or CSV, actually go and use this file, please. All right, so then, and this happens for dependencies, subdependencies, subdependencies, all the way down the tree, which is quite interesting, and it does all of this at runtime. So now we can start using packages that have transitive or peer dependencies without having to fork and ES modularize them like I did with React, for example. And this simplifies our application code too as well. In our Utils file, we can now just write this. We can get rid of all those unpackaged URLs, and every time that these import statements are read and parsed by the browser, they will get replaced with the correct URLs that we specified in our import map, which is a big win. So it turns out there's loads of extra features like this in the pipeline, and a lot of them are like at different stages of spec. But a really good place to find them is ES Module Shims, which is what the file I just recommended using. And in this README is a goldmine of like information on what to expect with regards upcoming ES module features. And it also proves as a polyfill and allows you to go like use all these features while browser specs and implementations are in flux, down to like IE 11, I think, maybe even earlier. I think he has a good compatibility table down there as well. But I did say there was 2 options available, and more recently, like very recently, over Christmas, Snowpack, something called Snowpack, you might have heard of it on Twitter, is going around and sort of making the rounds, if you like. And this is probably the brightest shining star in the ES module constellation at the moment. And it's a self-proclaimed unbundler. It doesn't modify your source code, and it doesn't run at runtime. Instead, it runs at install time, which is like this weird cross. It's not a build step. It's not a runtime like addition. It's somewhere in the middle, which is really interesting. So how does it work? Essentially, it scans all your code. It will go look in our utilities thing, and it will see that I want React, I want HTM, I want CSZ, and all the other things. And then it will go and fetch those. It will download them. Then it actually goes through all those dependencies, looks for other dependencies, and downloads them if it's needed. And it puts it all into one big file, like flattens your request, which is a very nice side effect. The only problem most people would say with that is that, well, you end up with these huge modules with all the dependencies and thing. So they actually built in tree shaking using rollup under the hood to get rid of any dead code that your app wouldn't be using, which is quite astonishing considering it's not a bundler, which typically the only way to get code splitting like this would have been through a bundler. And it puts all this resultant code, all the cleverness that's figured out, everything that you need and nothing more, into a folder called Web Modules, which sounds suspiciously like Node modules, but they're way better because every dependency is just resolved down to one file, one single file. Like you have react.js. You don't have React, the folder that when you open has a README and 10 other folders and 10 other files that you just don't need. It really does a lot of shrinking and packing for you. Hence the name, probably Snowpack. And if we were using Snowpack, our code would now have to look like this, really. All of these web modules will have been put in the right place and everything done, all the hard work, and we can just require them locally like this. That has the nice effect of, as well, if you're on a plane or a train, you can now actually dev, which is before you were going for https unpackage.com. If you weren't having a service worker, your site just wouldn't load and you wouldn't be able to dev on the tube, which I've come across more than once. So this is still quite a new tool, but it really points at a brighter future of building web apps at scale. Phew. So that was quite a lot of information to take in. It wasn't ridiculously hard concepts, but it was a lot. And so I thank you all for sticking with it. If you'd like to know more, though, I've tried to condense all of these learnings into one repository, which is called Create ES React App, which, disclaimer, it does need a big update. I have like 20 commits sat here on my machine, which I should just push, but I haven't. But it's still a good place to start if you're looking for more information about ES modules with React or another framework. And just a quick comparison to hark back. Create ES React App, you get 4,784 of them per gigabyte, which I think is much more reasonable. Here are some examples of that kind of architecture in production. Some of it's I've done with Formidable, some are personal projects. These are all bundler-less apps. They all just run at runtime. They have no node modules, etc., etc. All these repos are available, for all the products. They're all available on GitHub as well, so you can explore the code. But most of them are the same, really. So that brings me to the end of the adventure, and this is where I am at now, I guess. And in conclusion, the landscape is changing, like, quite rapidly. It probably feels more stable than it used to be, but it has changed, like, let's say. And sure, when there are fundamental shifts in paradigms, then people are going to find edge cases in the application of an idea that makes it inappropriate. But ES modular architecture is definitely a revolutionary concept within our language, and I'm pretty confident that it'll be sufficient for the majority of use cases going forwards. Fingers crossed. Please and thank you. Find me on GitHub.